Hello everybody, this is going to be the review video for 6.1 to 6.4, and I hope this helps you with the upcoming assessment that you guys have this Thursday. Okay, the first question says write an equation that's an example of an exponential growth. An exponential growth is going to be a number to a variable. The variable has to be positive, and the number has to be bigger than 1. So a number to a positive variable would be fine, something like 3 to the x. 1.4 to the x. Any of those would be totally fine. Sketch the graph of an exponential growth. Something like this. You're welcome to put your x-axis and y-axis anywhere you want. That's an exponential growth function. It starts off really, really small, and then grows very, very quickly, much like our virus that we're experiencing. An example that is an exponential decay is going to be a number in between 0 and 1. So in between 0 and 1, I'm just going to change this and make it a little bit cleaner. A number that's in between 0 and 1 raised to a positive exponent, or a number, so I'll just give you an example, something like 1/2 to the x. Or you could have 2 to the negative x. So you could have a negative exponent if you want to, and then a base that's bigger than 1. To sketch the graph of an exponential decay, it looks something like this. Starts off really, really big, and then goes really, really small, which we hope is the outcome of the current virus that we experience. What has to be true of an equation to make it an exponentially equal function? It's going to be a number to a variable. And again, the emphasis here is there's a variable in the exponent and a number as a base. Okay, number 2. You have a part-time job and you deposit $750 in an account that pays blah, 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 blah. Okay, and we have n equals 4. So n equals 4. The equation you're going to be using is a is equal p parentheses 1 plus r over n to the n times t. Okay, your p is your principal, and p in our case is $750. Your r is always a decimal, and the way you can get 3.35% as a decimal is 3.35 divided by 100. And if you do that, you get 0.0335, and that's a 0. T is always in years, so T is always in years, and it's going to be 5, and again, years. So 5 years, 3.35% interest, and the initial value. So now I can just plug them in, and I'll write it all out once first. If I was to rewrite this, I would get A is equal to 750 parentheses, oh, and n is 4, good. 1 plus 0.0335 over 4 to the 4 times 5. Now when I do that, and I don't have my access to my calculator, so I'll just do it on Desmos. When I do that, I end up getting out 0.0335 4 to the 4 times 5, and 4 times 5 is 20, so I'll just put 20 here. Just want to check everything. So $886.14 is your answer. $886.14. Okay, number 3. Graph the functions that include at least 4 specific points. So one way I could do this is just on the calculator and make sure that I'm graphing everything right. I do want to point out, though, that you will have a decay function for this one, because there's a negative exponent, number bigger than 1 as a base, and this one is going to be a growth function. And again, I could plug in points, like when x is 1, so with an xy table. For this one, x is 1, y is 2, x is 2, y is 4. When x is 0, y is 1, because 2 to the 0 is 1. And when x is negative 1, when x is negative 1, I get the reciprocal of 2, which is 1/2. So I can plot these points here. So 1, 2, 2, 4, 0, 1, and negative 1/2. And I get something that looks like this. I could do something similar with on this side with an XY table, or I could just pull up a picture 0 is 1. If I plug in 1, I get the reciprocal of 3, which is 1/3. If I plug in -1, then I get 3 to the negative -1, which is 3 to the first, which is 3. So I get 3 here, and similarly with -2, I just take the opposite sign for the exponent. I get 3 squared, which is 9. So -2, 9 is going to be right up here. I'm also just making sure you're aware I'm graphing 4 specific points. So -2, 9, -1, 3 is right here. 1, yep. I have 0, 1, which is right here, and 1 in the third. And that does look like a decay function. Starts really big and goes very, very small. And it should not go beneath the x-axis. I'm going to just change that for accuracy's sake. There we go. The asymptote for each one. The asymptote is this invisible line here that the graph appears not to cross. And the line that the graph doesn't cross for each one is going to be y equals 0. So my asymptote for each one is y equals 0. Equals 0 is the asymptote. Okay. Next, suppose that you have $6,000 to invest. One pays interest compounded continuously, and one pays 6% interest compounded monthly. So let's do the first one. $6,000 is going to be P in both cases. Okay. For the first one, account 1 pays 5.2% interest. So 5.2% will go to 0.052 when I divide it by 100, and that's R. Continuously, so continuously means I need PERT. And just get rid of that here, PERT. For account 2, again, still is 6,000. But it looks like account 2 pays 6% interest. So here R is 6% interest, which is going to be, when I divide it by 100, 0.06. Compounded monthly. Compounded monthly, let's get this here. That means N is 12. And I have to use this formula, parentheses, 1 plus R over N to the N times T. My time for both of these is 3 years. T is 3 and T is 3. So let's go and plug it in and see which one is going to get us more money. So I'll write this out just before I plug it in my calculator. 6,000 e to the 0.052 times 3. That's our first one. This one is going to be 6,000 times 1 plus 0.06 divided by 12 to the 12 times 3. Okay, let's see what we get here. I'll do the second one first. 0.056, I believe it was. And I believe this was 6,000. Let's just check this. 1 plus 0.06. Oh, 0.06. Divided by 12 to the 36. I messed that up slightly. Okay, I get $7,180 for this one. That looks like a nice healthy amount. So $7,180 for this one. Let's just get the change. And 8 cents. Okay, let's get the other one. 6,000, that one is so much easier to enter. 6,000 e to the 0.052 times 3. Just make sure that's entered right. $7,012.96. $7,012.96. Okay, and it looks like account number 2 wins. So account number 2 wins by about, let's see how much that would be. Just, I know it doesn't ask for it, but just in case it did. Minus 7,000. I just need to move this. So $12.96. So my $167, account number 2 is the better one. Okay, rewrite the following in exponential form. So just as a reminder for you, when you're rewriting these, whenever you have a log of a number to, actually I'm going to write like this. We have a log, base, number, answer. The way it works is you're going to have rewrite it to base to the answer is equal to the number. Now we could change this also, and I could change this to an exponent. I could change this to the exponent. And again, whenever you have, this says that a logarithm is an exponent. That's basically what we're saying here for number 5, that a logarithm is an exponent. A logarithm is a very, very fancy way for writing what an exponent is, or trying to solve what an exponent is. A logarithm is an exponent. Now this will be helpful at our new exit ticker. A logarithm is a different way to write an exponent. Okay, so to write these, again, I need a base. I need my base A to the exponent C equals B. And by the way, for all the time that I've worked with logarithms, this is always the form that I go to. If I'm ever unsure of how to do a problem. This one is 10 squared equals 100. I also want to remind you that this problem could have been rewritten as log of 100 equals 2. And whenever we do not write the base, there's an automatic 10 there as the base. And sometimes that's implied. Let's go to number 6. We're halfway done. Okay, to rewrite the following in logarithmic form. So again, what I had before was a log of base of a number equals exponent. And that goes to the same thing here, that a base to the exponent equals the number. Okay, the base here is 4, so we're going to do log base 4 of the number, which is 1 over 16, equals negative 2, and negative 2 is the exponent. You can do the same thing here, log base 3 of 81 equals 4. Okay, now to evaluate these, well, I'm always going to do some side work for these, so let's go and do 49. I don't know what it is, so I'm just going to put an x here. I'll say 49 to the x is equal to 1 over 7. And I notice that both numbers have a 7 in common, a power of 7 in common. So I can rewrite the first one as 49 is the same thing as 7 to the second equals, the 1 over 7 is the same thing as the reciprocal of 7, which is 7 to the negative 1. And now what I can do is I can just take these parts, the exponents, and set those equal to one another. In other words, as my class I always like to say, just drop the base. So what I end up getting is 2x equals negative 1. And again, the bases are gone now. So I end up getting 2x equals negative 1. And divided by 2, x is equal to negative 1/2. I want to tell you that this is kind of a longer way of solving the problem, but it will always work for the problems that we'll be doing. Again, we'll call this x for the second one. So I want 100 to the x equals 10. And I'm looking for, it looks like both of these numbers have a power of 10 in common. So 100 is the same thing as 10 squared. The x stays in the exponent. This 10 has a hidden number here. It's 10 to the first. And again, if the bases are the same, drop that base and set the exponents equal to one another. And x equals 1/2. Okay, let's go and do this one. 2. Alright, so again, let's call that x. You can 2 to the x equals 8. Both of these numbers have a base of 2 in common, because 8 is 2 to the third. Again, bases are the same. Drop that base, and you get x is equal to automatically 3. You do not have to solve for x any further. X equals 3. And then finally, log 1/2 of 128. So again, call this x. We get 1/2 to an x power equals 128. Now, I know that 1/2 is 2 to the negative 1. So let's go and do 2 to the negative 1x equals 128 is 2 to the, I think to the 7th. You can double check me on that. Bases are the same. So again, the whole idea when you're valuing logs is try to get the bases to be the same. Drop that base when you have the bases the same. You get negative x equals 7. Dividing by the negative 1 means that x is equal to x is equal to negative 7. Choking on my saliva. Okay. There we go. There's our answers for number 7. Let's go on to number 8. Oh, I love these problems. I want to remind you that natural log, anytime you see natural log of a number, that's the same thing as writing log base e of that number. And the reason that's relevant is because we have e to the log base e of 12. What I like to do is just draw a little line through these and I just get 12. Whenever I have a base raised to a logarithm with that same base, they cancel out. And it's beautiful. For this one, 81 over 3, I just simplify numbers with numbers here. 81 over 3 is 27. And since e is a number, I can do e to the 11th over e to the 5. E to the 5, and that's the same thing as e to the 11th minus 5, which is e to the 6. So I get 27e to the 6. Done. For this one, yeah, that looks fun. Again, it's the same thing that we had before, where we have, if we have a base to a number times a base to a number times this was from the last unit, to a number or a variable. What we can do is we can just write that all as one base and just add in between. So in other words, we can just drop everything here and we can do e to the 2x plus negative 7x plus 5. When you do plus negative 7x, you just get a minus. So our final answer is e to the negative 5x plus 5. And the way I got negative 5x, just in case you weren't sure, is I combined 2x minus 7x to get negative 5x. Alright, let's go to the next one, which is going to be a 2-second problem. I have a base of 5 and a base of 5 in my logarithm, and the exponent, those cancel. I'm left with 625. I love those problems. Let's see, same thing here actually. Anytime I have a log with the base, and then a base here of the same base with some exponent, cancels, and you're just left with the exponent. So, the 4 and 4 cancel, and you're just left with 3x. And again, ln is the same thing as log base e, so if I rewrote this, I get log base e of e to the 7th. This is the e to the 7th here. And same basis, this base and that base are the same, cancel them, and you're just left with a blue 7. I love those problems. Number 9, find the inverse function. So I didn't actually do this with my class, but we can still do it anyway, because there's nothing actually new here. F of x is y, number 1, so I get y is equal to 3 log base 2 of x plus 5. And let's just go and divide by 3 first. So we have y over 3 equals log base 2 of x plus 5. And now convert this to exponential form. And when we convert to exponential form, we use the base to the exponent, to the y over 3, equals x plus 5. And now solve for x. So I'm going to get 2 to the y over 3 minus 5 equals x. And then when you're inverting, switch x and y. Now this wasn't the only way of doing the problem. You could have switched x and y first. So my final answer here is going to be 2 x over 3 minus 5 equals y. You get the same answer if you switch x and y at the beginning and solve for y. For my class, I just want you to know, since we didn't do this problem in class or on video, that problem will not be on your quiz. Number 10, The following graph is y equals 2 to the x on the same grid. Also graph y equals 2 to the x minus 3 plus 1. Now it looks like there's a graph here. Okay, so we need to do 2x minus 3 plus 1. So let's do that. 2 to the x minus 3 plus 1. So the way I do these problems is I find a couple points that I can find. 0, 1 is one of them. And I also see, it looks like I can see 1, 2. Okay, well, to redraw this graph, minus 3 means I'm going right 3. The plus 1 means I'm going up 1. So that means I'm going to have this new point be 3, because I'm changing 0 and I'm going right 3. This 1 is going right 3, so that's going to be 4. And then for up 1, this 1 is going to 2, and this 2 is going to 3. And there's my new points. And again, I could have done that on the graph too. I'm just sending this point right 3. I go 3 here, I'm at 3. Up 1 is going to be 3, 2. So there's the first point, very bad picture here. And I also have 4, 3, similar concept. And then I'm just going to draw this graph again. Horrible picture. Basic idea. Please also note that your asymptote also moves up. It's going to get this here, it's going to get this, get this, and then it's going to get that. Okay, so here's my asymptote. Nope, that's not it. Show it again. Okay, so there's my asymptote, and the asymptote moves up 1 because, and I don't think you're going to be testing this, but just in case, because of that plus 1. Let's do the same thing with the graph here. We want to do on the same grid, also graph y equals L. And okay, this covers the inverse. What it's basically saying, now that's kind of a tougher problem. So, first of all, the inverse of e to the x is y equals L of x. They're opposites of one another. Not opposites, they're inverses of one another. Ln of x goes right here. And it doesn't grow that fast at all. Ln of x is actually a very slow-moving graph, if you didn't know that. Okay, so it goes like this. So to move this graph, we have to go left 3 and down 4. And again, you could have just plugged this into your calculator if you wanted to. Let's do that for this one. Ln of x plus 3 minus 4. Good table here. Okay, so we have negative 2, negative 4. 2, negative 4, which makes sense. Because we went left 3 from 1, 0 and down 4, so that makes sense. And it looks like we have another point like, let's do 0, negative 2.9, which is basically 0, negative 3. And please notice that there's also this vertical line now. It's at x equals negative 3. That's the vertical asymptote. That means the graph cannot touch x equals negative 3. And to sketch the graph, we're going to have something like this. Okay? So in doubt, when in doubt, there's a graphic out there. And then finally, for our last problem, given the graph that is a transformation of f of x equals log base 3 of x, write a rule for g of x. In the picture, g of x is drawn solid and f of x is dotted. Transformation only involves slides. So the points that I'm looking at here, the points that I'm looking here are going to be this one and that one. And I notice that on the purple graph, I see this point and that point, and it looks like they moved. So what I'm going to do is I'm going to just slide this guy that way. That looks like it went left 3, 1, 2, 3, left 3. And it also looks like it went up 4, 1, 2, 3, 4. I'm just going to check with the other point and see if that did the same thing. Let's see, this went left 3. Yep. It also looks like it went up 4. Perfect. So my transformation then to go left 3, log base 3 of left 3 is going to be x left 3, left 3, left 3. Plus 3, remember to do the opposite. They're going in a negative direction, add 3 instead. And to go up 4, and that's my new equation for g of x. Alright guys, I really hope this video helped you. I believe that's all the problems. Thanks for watching.